Today we're going to start section 10.2, finding arc measures. A circle measures 360 degrees. A central angle of a circle is an angle with its vertex at the center of the circle. So we can say angle ABC in this circle here is a central angle because its vertex B is the center of the circle. An arc is a portion of the circle defined by two endpoints. So we can say if we take endpoint D and endpoint A on the circle, we can say the portion of the circle between those 2 points is arc DA. A minor arc is an arc that measures less than 180 degrees. Its measure is equal to the measure of the central angle. And it is named by its two endpoints. So if we take a look at the minor arc here, we can say arc AC, so this arc here on the circle, is a minor arc because it measures less than 180 degrees, and we can find its measure by looking at the measure of its central angle. So angle ABC is its central angle. That angle measures 93 degrees, so we can say the arc AC also measures 93 degrees. A major arc is an arc that measures greater than 180 degrees. We can find the measure of the major arc by taking 360 and subtracting the measure of the minor arc. And it is named by two endpoints and another point that lies between them on the circle. So if we take a look at arc ADC, ADC is a major arc because it measures greater than 180 degrees. And to find its measure, we can take 360 degrees, which is the total measure of a circle, and subtract the measure of the minor arc. We said the minor arc measured 93 degrees, so we can do 360 minus 93, and we get 267. For examples 1 and 2, we're going to name the red minor arc and find its measure, and then the blue minor arc and find its measure. So for example 1, our minor arc, the red minor arc, we can name it arc AB, and its measure is going to be equal to its central angle. Its central angle measures 135 degrees, so we know the measure of arc AB is 135 degrees. The major arc, we can name it arc ADB. Remember, it's two endpoints and then another point that lies on the arc. And we can find the measure of this by taking 360 and subtracting the measure of the minor arc. 360 minus 135 is 225 degrees. Try example 2. The minor arc we can name arc EF, and we know the minor arc is equal to the measure of its central angle, which is 68 degrees. The major arc we can name arc FGE, and to find the measure of the angle of the major arc, we take 360 and subtract the measure of the minor arc. 360 minus 68 is equal to 292 degrees. A semicircle is an arc with endpoints on the diameter of a circle, and it always measures 180 degrees. So a semicircle is half of a circle. We know that the entire circle measures 360 degrees, so a semicircle will measure half of that, which is 180 degrees. Adjacent arcs are arcs that are on the same circle and share a common endpoint. So two arcs that are right next to each other. And the arc addition postulate will be used to find the measure of an arc formed by two adjacent arcs, and that's going to be the sum of the two measures. If we take a look at example 3, We want to identify if the given arc is a major arc, minor arc, or semicircle, and then find its measure. So we're first going to look at arc BC. BC is a minor arc because it measures less than 180 degrees, and it's equal to its central angle, which is 70 degrees. Arc ED is also a minor arc, and it's equal to its central angle, DFE, which measures 45 degrees. Next we have DC, again another minor arc, and it's equal to its central angle, which measures 65 degrees. Next we have AE. Arc AE is also a minor arc, and it's equal to the measure of its central angle, which is 70 degrees. Next we have arc EAB. So remember, it starts at E, it goes through point A, and ends at the other endpoint B. Here we have to use the arc addition postulate. We're going to have to add up two minor arcs to find the total measure. So we have 70 plus 110 degrees gives us 180 degrees. Because it measures 180 degrees, we know it is a semicircle. It's half the circle, which also tells us that segment EB is a diameter of the circle. Next we have ABC. So again, starts at A, goes through B, and ends up at C. We're going to add our two minor arcs together to find the measure of our arc ABC. So we have 110 plus 70, again gives us 180 degrees. So we know this arc is a semicircle. And we can say segment AC is a diameter of the circle. Next we have BAC, so we start at B, go through A, and land at C. This is going to be a major arc because it is greater than 180 degrees. It's bigger than a semicircle. And again, we're going to use the angle addition postulate. We're going to add up all of the minor arcs that make up the major arc. So we have 110 plus 70 plus 45 plus 65. So when we plug that in our calculator, we get 290 degrees. That's the measure of arc BAC. And our last one, we have EBD. So we're going to start at E, go through point B, and land at point D. So again, we have a major arc. It's greater than 180 degrees. And again, we have to add up all of our minor arcs to find our measure. So we have 70 plus 110 plus 70 plus 65. And we're going to get 315 degrees. Please pause your video and try example 4 on your own. So for example 4, for the measure of arc JL, you should have gotten 132 degrees. The measure of KM is 147 degrees. The measure of JLM is 200 degrees. And the measure of JM, here we had to take the measure of an entire circle, 360, and subtract the arc JLM, which measures 200 degrees, and we got 160 degrees. Let's take a look at example 5. So it tells us that AC and EB are diameters of the circle. We're going to identify each arc and then find its measure. So before we start, I think it's most important that we find all of our missing central angles. So we have to find angle ARE and angle ARB. So if we take a look at angle ARB and angle CRB are actually vertical angles, and we know that vertical angles have the same measure, so we can say that this central angle also measures 50 degrees. Now to find angle ARB, we know that EB is a diameter of the circle, which tells us that arc EAB is a semicircle. It measures 180 degrees. So we know that angle ARB and angle ARE must add up to equal 180 degrees. So we can do 180 minus 50, which equals 130 degrees. So we know that this angle measures 130 degrees. Now that we have all of our central angle measures, we can go ahead and find our arc measures very quickly. So the first one we have is EA. We found that central angle to be 50 degrees, so we know that the measure of arc EA is 50 degrees. Next we have CB. Its central angle also measures 50 degrees, so we know that the measure of arc CB is also 50 degrees. Next we have DC. Its central angle measures 100 degrees, so we know that the measure of arc DC is 100 degrees. Next we have DEB, so we're going to start at D, go through E, and swing all the way around to B. Here we're going to add up all of our minor arcs to find the measure of our major arc. So we have 30 plus 50 plus 130. Which equals 210 degrees. Next we have arc AB. We said its central angle measured 130 degrees, so we know arc AB also measures 130 degrees. And lastly, we have arc CDA. Arc CDA, we have to add up all of the minor arcs to find its measure. So we have 100 degrees plus 30 degrees plus 50 degrees, which is going to give us 180 degrees. Now we can go back and identify them very quickly. So we know EA is a minor arc because it's less than 180. Same thing with CB. DC is also a minor arc. DEB is a major arc. It's greater than 180. AB is a minor arc. It's less than 180. And CDA is a semicircle. It's equal to 180. Congruent circles are circles with congruent radii, so they have the same measure for their radius. Congruent arcs are arcs that have the same measure either in the same circle or in congruent circles. So we're going to determine if the arcs are congruent and explain why or why not. Arc CD and arc EF are congruent. So CD is congruent to EF because they have the same measure in the same circle. For number 2, UV and YZ are also congruent because the circles are congruent and they have the same measure. Please pause the video and try numbers 3 and 4 on your own.